Okay, now we're ready to look at the read methods for the list of integers. And let's just go back, take a look at the design and see what this means. So I'm overloading the read method. And I'm doing that because I want a programmer to be able to pass in a file name, or if they have an open input stream, then they can pass that as well. Now, of course, what this read method with the string argument is going to do is it's going to open an input stream. And once it does that, I can just call this second read method that takes the iStream as the argument. What's going to happen is, if I have some file with some integers in it, then I want to create the linked list that looks something like this, right? I'm going to have head pointer, and initially head pointer is going to point to null because of my default constructor. And the first thing I'm going to do is I'm going to read out the integer 5, and that actually should be the first node of the list. 10 should be the second. 15 should be the last. Now I can't change head pointer. Remember that. So I'm going to read out 5, and it will be easy to create a node of 5 and make head pointer point to it. And remember, this happens because of the default constructor of the node class. Well, now when I read 10, how do I get 10 out here? Well, if you go back and look at the example in main where we were creating this linked list, I actually used temp pointer to always point to the last element of the node. So see, it starts at the beginning, and then after I add the node, then I advance temp pointer, so temp pointer is always pointing to the last element. And if I'm pointing to the last element of the linked list, it's very easy for me to add a node on to the end by using this statement. So that's how I'm going to do it. However, it's a special case where we're adding the first element of the list. So when we add the first element of the list, head pointer will point to null, and then after we do that, that's how we want our list of ints object to look like. Then when we read 10, we can add 10 here. Then I'll advance temp pointer, and then I'll add 15 here, and then I'll be finished. The other thing that we have to remember is our pattern for reading objects out of a file. And generally the way that we want to do that is we want to say input. We want to say input, and then while I have input, then I want to process the input, and then I want to go back and get input again. So it's important to remember that. So what we're going to do here is we're going to read an integer, and our processing is going to involve this check. The first check we're going to do is if head pointer points to null. If it is, then we're going to make head pointer and temp pointer point to this new node. But then every time after that, we know that we have a node and temp pointer points to the end, and we'll just be adding on to the end and advancing temp pointer. Once we've done that, we go get another integer, and we just keep doing that as long as we have input. And eventually we read the end of file marker, and we'll stop. So the first read method is going to take a string. I'm going to leave off the constant. And this is I'm going to use this to open an input file stream. And I'm going to call it fin for file input. And I can just pass this file name into the constructor. Although remember that I have to use the C_str method to convert that to a C string. Now this is either going to succeed or fail. And this object will evaluate to true if it succeeded, meaning that this file exists. So if fin is true, then I want to pass it on to the read method. Just like that. Oh my goodness, look what I did. You see what I did? I forgot to put here colon, colon, read. I bet you saw that mistake, didn't you? And you didn't even point it out to me. All right, so that's going to work fine. And so now we're going to implement the second method that takes this time I'll write it correctly. And it's taking an iStream, just like that. So the first thing I need to do, and this is a subtlety that is really important that will create a memory leak if we don't deal with it correctly. So let's say that I have an LOI object, a list of integers, and I call read on, numbers.dta. And so there are some integers in here, and I'm going to read them in, and I create this linked list. And let's just, say that there are only 3. Okay. And let's say a few statements below that, I call read again. Or someone using your class calls read again, maybe on the same file, maybe on a different file. And so what is going to happen? Well, if you're not careful, you're going to leave these nodes in memory and create another list. And if they do it again, you're going to leave those nodes in memory and create another list. You can't trust that the programmer is going to call clear before he or she calls read. So we're going to be responsible for making sure that we destruct this list before we actually read numbers again. Now, this is a design issue. This is how I'm choosing to implement read. Maybe we implement read where it appends onto the end of the existing list if there is an existing list. That's fine. Either way you want to handle it, I'm going to handle it this way because we already have a clear method. Well, how do we know if we have a list? Well, we know because head pointer is not pointing to null. So if someone calls read and head pointer does not point to null, then we need to call the clear method and make it point to null. So if we have a situation where there is a list, we know that it will get destructed, and we know that head pointer will point to null. Now I'm going to need an integer for reading, and I'll just call it x. And I'm also going to need a pointer that will always point to the last node of the linked list, called temp pointer. And I'm going to start off having that point to null. Okay? And the next thing I'm going to do is I'm going to read an integer from my input stream. Now, it could very well be that the file is empty, so it opened, but it's empty. And if that's true, then we won't enter this while loop here. But let's assume that I have read an integer, and now that's going to be the first node in my chain. And I need to make head pointer and temp pointer point to that. How do I know if it's the first node in my chain? Well, head pointer will point to null. So if head pointer points to null, and I'll do a code trace when I get finished with the implementation. This is the first node of the chain, so I want head pointer, the first node of the linked list, I want head pointer and temp pointer to point to this new node. And what value should this new node store? Well, it should store the value I just read, so I can pass x to the constructor. Otherwise, I'm going to write this code over here. So otherwise, and I'll fill that in just a minute, but this is going to be the block where we handle the case of adding on to the end of the list. Okay? So I just created a one element node, and head pointer and temp pointer point to it. Well, now I need to go back and get another integer. So I read the next integer from my file, and this is going to be the end of the while loop. Okay? Assuming there is another integer, like 10, it's now stored in x. I come back to here, n will evaluate to true, and I enter my while loop again. Well, now this is false because I have already added the first node. Head pointer points to that first node. So what I need to do is I need to add the new node onto the end of the back of the list, to the end of the list. Well, temp pointer points to the end of the list. So I can say that temp pointer set next pointer, and I want that next pointer to point to a new node that contains the x that I just read, just like that. Now I can advance temp pointer by saying get next pointer. Just like that. And so that's the implementation of my read method. Here's the end of read. And what I'll do in the next video lecture is I'll write this out in a bit neater format, and then I'll do a code trace and show you how it works.